Hey guys, today we're going to talk about absolute value inequalities. And last thing we talked about were compound inequalities, and they are very much related. Absolute value inequalities basically come in two flavors, where the absolute value of some expression is less than a number, or the absolute value of some expression is greater than a number. Now hopefully you remember that absolute value of something just means its distance from zero on the number line. So when we say the absolute value of some expression is less than b, what we're talking about is that this b, whatever number it is, we're saying what are all the numbers that are less than b from the number line? Well, all these numbers all the way to 0, but also negative b all the way there. So as an example, let's say we were talking that this was 5, okay, and so whatever that expression is less than 5 on the number line, okay. Basically what we're saying is everything, all the numbers less than 5 and all the numbers greater than negative 5. So that means our solution set is in between these two boundary points, and that's why we can put inside as a way to remember this. And also, if you remember our last lecture, these are AND type of inequalities, compound inequalities. As for when the absolute value of some expression is greater than the number b, well, that now means those numbers that are bigger than b from 0 on the number line. So all these that go out in this direction, and negative b, all these that go out in this direction. And if you recall that this means everything that is outside the boundaries, and this was an OR type of compound inequality. What the solution sets look like for these are graphically, again, are something like this, and this I just put a couple boundary points in here. For an AND, we're saying that x is less than some boundary point but greater than some other boundary point, and this is an AND because there are numbers in between 1 and 5 that satisfy, I should say, both of these inequalities. For an OR, just like the name says, OR, there are numbers that have to be either greater than 5 or less than 1. They just have to satisfy one, at least one of these two. So it's best to take a look at a couple of examples. So our first example is a very basic one. I'm asking you which value of x can I put in here that will be less than 3 away on the number line. Well, what's values of x? Well, what will make that true? Well, first of all, let's find out what is 3 away from 0 on the number line. Well, negative 3 and 3. So when we say what values of x can I put in here that'll be less than 3, well, really it's anything in here. Any of these numbers. Any one of these numbers that if I took and plugged into here, like let's just take negative 1 for example, negative 1, I plug into here, the absolute value of negative 1 is 1, which is definitely less than 3, so that satisfies the inequality. So what we're going to do though is write this as a compound inequality. In other words, I want to make sure that I understand that whatever I'm looking for has to be some number that is less than 3, as we see here, but it also has to be greater than negative 3. Now notice the orientation of these and how you can visualize it like this, that these inequalities have the sense in the same direction, and that I've just taken 3 and its opposite here. And notice I've just taken away the absolute value signs. Now what that does is let you know the two compound inequalities. X is greater than negative 3 and x is less than 3. Here's what our solution set would look like. Okay, let's look at the other situation where the absolute value of some number is greater than 3, and what x makes that inequality true. Well, we have the same boundary points, but now we're saying what values would make it farther than 3 away from 0 on the number line. Well, all those numbers over here, 4, 5, 6, that's all greater than 3, but also all these over here, all x's that are less than negative 3, right? Again, just take an example. How about negative 6? If I plug negative 6 in there, the absolute value of negative 6 is 6. Is 6 greater than 3? Absolutely. Okay. So now this is, of course, a case of the OR type of inequality. And written as a compound inequality, we would have this. X is less than negative 3 or greater than 3. All right, let's solve a couple of easy problems. Okay, we want to solve and graph this inequality. And it says the absolute value of 3x is less than 15. So again, just looking at what this is saying is that what value of x will make this expression 3x less than 15 units away from 0 on the number line. So basically I want all the numbers that will make the expression less than 15 numbers away from 0 on the number line. So all the stuff less than 15 or greater than negative 15. So in writing this as a compound inequality, I'm just going to take my expression. I'm going to take it has to be less than 15, but it also has to be greater than negative 15. And now I want to find out what x's will satisfy this compound inequality. And like we've done in the past with the compound inequalities, we just take them one at a time as two separate inequalities. Here we divide by 3. I have x is greater than negative 5. Here's my boundary point. Divide by 3. I have x is less than 5. All x is less than 5. All x is greater than negative 5. That's my solution set, or at least the graph of my solution set. And my solution set is here. All x's that are less than 5 and greater than negative 5. Okay? Let's see if you can figure out how to do this one. Okay, again, I want to find an x that's going to make this expression less than or equal to 2 away from 0 on the number line. So essentially, I'm going to write a compound inequality again, and here's the way I do it. Again, I keep an idea of the sense of the inequality, and now I just have two inequalities that I solve one at a time. This will give me the two boundary points. Add 3, and I have x is greater than or equal to 1. Add 3, I have x is less than or equal to 5. It is, of course, an AND. So let's try the next one. Go ahead and give this a shot. Okay, now I want to find the value of x that's going to make this expression farther from 2 on the number line. Again, let's write a compound inequality. Again, notice the way that this is, and the way I set it up, take the opposite of that 2. Pop it over here. And I just solve them one at a time. Again, notice that this is one inequality, and this is our other inequality. Each of these will give me boundary points. And once I have the boundary point, I just have to decipher it. X's are less than 1. So I graph it. And x is greater than 3. I graph it. This, of course, is an OR. And I have this as my solution set. Okay. Try that one. Okay, here I want to get the absolute value alone here, because what I'm saying is 3 plus some number has to be greater than 5. So what numbers have to be greater than 5? Well, there's a lot of them, but I want to know exactly which values of x, that set that's going to make these greater than 5. Well, I want to get this alone, because I know that if I subtract 3 from both sides, I know this absolute value has to be greater than 2. So now I can write it as a compound inequality. Solve each inequality individually. Here when I subtract 2, I get x is less than negative 4. And when I subtract 2, I get x is greater than 0. So I notice that it's an OR type of graph where x is less than negative 4 and x is greater than 0. Try this one. Okay, I want to get my absolute value expression alone again. So this time I'm going to divide both sides of the expression by 2. Remember, we really discourage you from distributing it into here for several reasons that we spoke about before. But if we divide by 2, we get to this situation. Now we can write it as a compound inequality. Solve both sides of it, or both inequalities. Gives us one boundary point at 1. gives us the other boundary point at 9. Says x's are greater than 1 and x's are less than 9. Obviously this is an and. This would be our solution set. In our last example, give it a shot. Okay, again, let's turn it into a compound inequality. Solve them one at a time. I'll take this one off the left. Subtract 1, divide by 2. I have a boundary point at -3. It says all x is greater than or equal to. Subtract 1, divide by 2. All x's that are less than or equal to 2. Obviously it's an and. And here is our solution set. Okay, that's it. Here were our homework problems. So if you want to take a look at those. And here are the solutions to the homework problems. So you can pause it and check that out as well. All right, we'll see you tomorrow.